Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 276. Page 276, and today is our lesson number 16. Please turn to the page, the very first problem on the top of the page, number 12. Number 12, read the problem to yourself. It says the water is being pumped into a partially filled tank at a rate of inlet, so on and so forth. They make it mumbo jumbo. This is the gist of it. Water is being pumped in. Water is being pumped into the tank, and at the same time water is being pumped out of the tank. The question simply is, how fast is the water level rising? The mere fact that they're asking us how fast the water level is rising tells us that the rate of water coming in must be greater than the rate at which the water is leaving the tank. The net flow is positive. The question is, how fast is the water level rising? Let's look at the first statement. The first statement tells us that the initial level is 200 gallons. Well, this knowing initial level is 200 gallons, this is a worthless information for us. How is that going to help us answer the question? What we want to know is, how fast is the water level rising? So my knowing what the initial level of water was in the tank is useless. It doesn't do any good. We are interested in a rate of change. We're not looking for what it was initially. We want to know how fast it's coming in and how fast it's going out. We want to know the difference between the two rates. This is useless. First statement by itself does no good. So here we go. A, D, B, C, E. Since the first statement does not work, the answer cannot be A, it cannot be D. Let's look at second statement. Second statement tells us that it is coming in at 10 gallons per minute, and it's telling us that it's going out at 10 gallons per 2.5 minutes. Voila! Very good. Now we are getting someplace that should do the job. We don't actually have to figure out the net inflow. We just have to realize that since we know the rate of inflow, we know the rate of outflow, we can figure out the net rate of change. How fast is the water rising, which is the net of how fast it's coming in minus how far it's going out. And we know both of those information here. So second statement by itself does the job. The answer is B. Okay, that's it. We're done with this problem. The work that we're going to do from this point on is just purely out of curiosity. Let's just find out what it is. There are a couple of ways you can tackle to figure out the net inflow. You can either convert this into, this is per minute, this is per 2.5 minutes. 10 gallons per minute would be same as 20 gallons per 2 minutes, which is same as 25 gallons per 2.5 minutes. So it's coming in. It is coming in at 25 gallons per 2.5 minutes. It's going out at 10 gallons per 2.5 minutes, which means the water level is rising at 15 gallons. Water level is rising at 15 gallons per 2.5 minutes. That's one way we could have tackled it. Another way we could have figured out how fast this is changing, which is weird because typically one does not express the rate of change in terms of per 2.5 minutes. Typically one expresses the rate in terms of per minute. So let's do that. Let's do per minute. So we're not going to mess with this one. Let's mess with that one. We are told that it's 10.5 per 2. We are told that it's 10 gallons per 2.5 minutes. So 10 divided by 2.5, which is 4 gallons per minute. Voila. So it's coming in is coming in at 10 gallons per minute, is going out at 4 gallons per minute, therefore the net inflow is 6 gallons per minute. Of course, we didn't have to do that, you understand that, obviously. These are called data sufficiency. Nobody is asking us to actually figure out anything. All we have to do is to be able to tell if there is enough information to answer the question that is being asked. And the answer to that question is yes, we do have enough information. Enough said, let's do one more. Next one, number 13. Number 13. It says, in number 13, all they are asking is if x is negative. Number 13. Is x a negative number? That's all they're asking. The first statement tells us that 9 times x is more than 10 times x. Well, if 9 times x is more than 10 times x, then x must be negative. X must be negative. This implies that x must be negative. Why? 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 Because if x were positive, it's a hypothetical statement. One is speaking hypothetically. If x were positive, 9 times some positive number cannot be greater than 10 times the same positive number. 9. How can 9 times positive 3 be greater than 10 times positive 3? Of course it's not. We are being told that 9 times some number is greater than 10 times some number. So that number that we're talking about must be negative, because obviously positive 27 is not greater than positive 30. But negative 27 is greater than negative 30. Voila. Negative 27 is greater than negative 30. X must be negative. X has to be negative. That's the only way a 9 times a quantity can be greater than 10 times the quantity, is when that quantity in question is a negative quantity. Statement 1 works. Statement 1 does the job. Just put down here A, D, B, C, E. Since statement 1 works, the answer cannot be B, C, or E. It's got to be either A or a D. Let's look at the second statement. If it turns out that the second statement also does the job by itself, then the answer would be D. If it turns out that the second statement does not do the job by itself, then the answer would remain A. Let's look at the second statement. In the second statement, they tell us that x plus 3 is positive. X plus 3 is positive. Does that tell us what x, does this enable us to figure out whether x is positive or negative? The answer is no. For all we know, if x plus 3 is positive, x could be 1, x could be positive 1, positive 1 plus 3 is positive, or x could be negative 1. Negative 1 plus 3 would be positive 2, and this is still positive. We cannot tell whether it's positive 1 or negative 1. That's one possibility, or this is just one possibility in the millions of possibilities, because here it doesn't even say that it has to be integers. I'm just assuming that is an integer. Even if it were integer, we do not know whether it's positive 1 or negative 1. Or x could be positive 2 or negative 2. A positive 2 and a positive 3 is positive, and a negative 2 and a positive 3 is also positive. We have negative 2 plus a 3. If x is negative 2, negative 2 plus a 3 would be positive 1. And if it were both positive, we cannot tell. Simply knowing that x plus 3 is positive is not going to tell us whether or not x itself is negative. It may be, it may not be. Second statement does not do the job. The answer is A. The answer is A. Statement 1 only by itself answers the question. Statement 2 is worthless. Alright? I will see you tomorrow. Bye now.